Hello, this is a video to explain the vector addition of components that may make up a series of interactions on a particular object. So, for example, let's say that you had a stationary object and a force hit it from the left, a force hit it from the south, and a force hit it from the west, from the right. Those three interactions all act on that same object. There's a way in terms of adding those vectors together in order to determine the final resultant of the angle and magnitude the object would go off at. So this illustration here is just to give you a quick tutorial on how to break down that information in order to get an answer like that. So a problem that is in your homework that some of you may have received shows a resultant vector of a magnitude of 12 with an angle of 53. I think it says in it in one particular example, negative 37 from the vertical. Well, negative 37 from the vertical is the same as 53 from the horizontal, and you measure 53 and is a positive value. Generally, we would say 37 from the vertical would be a negative 37, showing its direction. But the point is, the 53 is the value we're going to use for the triangle we make, the right triangle that we make from that vector. And that then you can see gives us A as the resultant, and we're given that value as being 12. Then A sub x would be the horizontal component of that vector, and then A sub y would be the vertical component of that vector. Now, in order to solve this, so if I have, before we say that, if I have this angle, this vector, and then I have another vector coming over here into quadrant 2 and another vector coming over here into quadrant 3, I would have to do this for each one of those to find the resultant of all three of them acting on the object that's here at the center. And then after I get each component, then add all the x's, all the y's to get my resultant x and my resultant y to find my resultant angle and magnitude of the vector sum of those three angles, three forces. And so this is just one of those. So this is that 112 magnitude at 53 degrees. To break this up, I'm going to say for A sub x, I would say cosine of 53 is the adjacent side over the hypotenuse. And so cosine of 53 equals A sub x over 12. Then I would solve that by taking the cosine of 53 times 12 to get A sub x right here. Then I would say, all right, sine of 53 is the opposite over the hypotenuse, A sub y over 12, and that's here. So sine of 53 times 12 would give me the A sub y, or vertical component of this particular vector. So now I would have A sub x, A sub y, and 12 being the resultant. And I would also know, logic would tell me that these two numbers are going to be less than 12, and that this number is going to be larger. A sub y is going to be larger than A sub x because my angle is greater than 45 degrees. At 45, these two would be the same. Some basic ways to keep yourself in check to make sure that your numbers are in agreement. Then after I have these components, I'm done with this particular part. I would do this for my other two components. And then at the end, sum all my A sub x's with all the ones going to the right being positive for x, going to the left being negative, add and subtract those. Y is going towards the positive of the 90-degree angle direction, is positive, going south, if you will, is negative, and add and subtract those. and get my sum of my a sub y's and a sub x's, plot them on a new Cartesian plane. And then I can use the Pythagorean theorem to find my third side. C squared equals a squared plus b squared. Or I can use my tangent function, tangent of my unknown is opposite over adjacent, and that would give me my angle. And then when I have my angle, I can find that third side. So these are the ways in which I can make this solution.